welcome you all to the first meeting of 2023, so Happy New Year to you all. It's great to see the numbers right up this month. There are some signing boards going round. Please can you make sure that everybody signs it? I'll explain a little bit later when we look at some of the meetings. We are looking and needing collaboration information about how many people come to the meeting for various reasons with the ICE, so we do need to know exactly how many are here tonight. It'd be great. Okay, right, moving on to this evening's presentation. We have two presenters doing a presentation on HS2 Area North, an overview of the activities on the Long Itchington Wood and Bromford Tunnels. Our two presenters are Jules Arlaud. Jules has spent 12 years working for VINCI construction projects in both France, Chile and the UK. Jules is currently Deputy Project Director at Balfour Beatty VINCI on HS2 for Sublot 1, and this includes the presentation and tunnel that they're going to talk about tonight. His co-presenter is Mark Merry. Mark has 35 years experience in tunnelling, dating back to Docklands Light Railway, Bank Extension and Channel Tunnel, before a lengthy period overseas, working at Lesotho Highland Water Project, Hong Kong DTSS, and then 20 years in Singapore as the tunnel manager on various EPB and slurry projects for the Singapore MRT project. He was also the Southeast Asia regional manager for the French TBM NFM, taking the company from a zero market to €100 million in 4 years. On his return to the UK, he's worked on Humber Crossing, Chester Storm Water, and now is working for BBV at HS2. Okay, over to yourself.
Good evening, everyone. Thank you all for coming tonight. So I'm Jules. Thank you, Arlaud, for the introduction. So I'm the Deputy Project Director for BBV, which stands for Balfour Beatty VINCI joint venture, on the HS2 Phase 1 project. So as you can see on the screen, our topic today is a presentation of our 2 TBM operation at Long Itchington Wood in Warwickshire and Bromford in the northern suburb of Birmingham. Briefly, BBV was awarded the Area North of the Phase 1 of HS2. It is a 90 kilometre of this 230 kilometre of this first fold of the HS2 project. As a main work civil contractor, BBV ought to deliver 300 assets, among which 9.3 kilometres of viaduct, 62 overbridges, and of course 7.3 kilometres of tunnel. Our project is split into 3 delivery functions: major structure, main line, and the tunnels, and in 8 sublots, each one the size of a major project. The sublot itself consists of a dozen of assets in 2 construction areas, which are 30 miles apart. So you can see here the project in itself. So we have one at Long Itchington, so the north is over there, Long Itchington at the south, and Bromford when we are entering Birmingham area. Just briefly, in our integrated project team Area North, so we have employees from HS2, BBV and DGV. The ABD is a particular form on the basis of a co-location organization that is unified as a single in order to deliver this railway for the future. So this challenge starts and finishes with the people, of course, and we are looking at 9,000 people at the peak to be working, among which a special focus is given to local labour. As for Sublot 1, we are looking at 400 staff at the peak, with more than half of it already on board. So in order to achieve our tunneling programme, the design joint venture, which is Mott MacDonald and Sistra, has already accumulated more than 100,000 hours of work, with 57 resources spread across 7 countries in the world. So that to deliver circa of 5,000 documents for this Sublot. So you see here some numbers of what we have to deliver, in terms of design, which is the first challenges of every project. So this was a overview of the BBV Area North and the Sublot. Here now is Mark Mary, the Long Itchington Wood Tunnel manager, to talk about the first drive completed on HS2 and the operation at Long Itchington. Mark?
Thank you, Jules. Which is which? It's the laser, okay. Right, thank you, ladies and gentlemen. As you know, you heard from there, I've had some experience within the tunnel industry. It's nice to see some old faces out there, and nice to see some young faces as well. So, Long Itchington Wood Tunnel is a 1.6 kilometre twin bore tunnel going from North Portal through Long Itchington Wood to the South Portal, where we have various structures such as green tunnels and porous portals. This is an overview of the project, and this is the key reason why we are building this tunnel. This is Long Itchington Wood. This is an ancient woodland dating back to about 1600 AD. So obviously that's an SSSI, and the reason that we're doing these tunnels is to preserve this natural habitat. So this is a view from the North Portal going down to the South Portal. The tunnel there, the up tunnel, no, it's the down tunnel because it's going down from London, is completed, and we're now doing Drive 2. Looking at the geology, mainly composed of Mercian mudstone. It's a very, very simple geology. There's been no shocks, no surprises, which is always nice. The only real surprise we've had is the Blue Anchor Formation, a little bit cloggier than we wanted to. The ground, very low permeability. So the 6 cut-ahead interventions that we've done have all been in free air. We've been very lucky that way. We've had some clogging, as I say, and we'll go into that in more detail later. Because we're going through a wood, obviously our instrumentation is fairly minimal, but as I'm going to get into later, we've put instrumentation in the woods, mainly surface levelling points, extensometers, inclinometers and piezometers, to check the progress and to check the viability of the machine we've been using. So the main bore tunnel's got 2 1.6 kilometre tunnels, Herring Connect variable density machine called Dorothy. Called Dorothy after a local resident called Dorothy Hodgkin, she was the first female recipient of first UK female recipient of the Nobel Prize for Chemistry, and that was done after consultation with local stakeholders. Tunnel diameter 8.8 metres. Segments are a steel fibre reinforced segment chosen for their durability. We have special segments for the cross passages with reinforcement and also some heavy rings at the front and end of the tunnel for supporting those areas of low cover. As I say, the TBM is a variable density machine from Herring Connect. And in that 1.6 kilometres of excavation, we have 3 cross passages which will be excavated in traditional means, hand excavation, sprayed shotcrete lining, and then concrete finishing. So looking at our site installation, that's what we look like in 2022. STP, a large STP to deal with the size of the TBM. Filter presses banging out 170 tonnes of 170 tonnes of filter cake per hour. Segment storage, 70 rings. And we've got 3 MSVs in the project along with 1 PSV for transport. STP's there, segment yard, segments are loaded onto the MSV and run down to the portal. We also have on here, which you can't see, we installed a conveyor across to a neighbouring sublot to help us with our muck away. So TBM launch preparation, it's a fairly standard TBM launch preparation, standard reaction frame. What was interesting was when we build the machine, we build a steel ring within the tail skin, and that's our first permanent ring. So we build it in the tail skin when the tail skin is horizontal, and we flip them both up, and that gets us our first ring built. Traditionally, on the smaller diameter machines, I know we build the concrete rings up along the side and then dog them in, but with this large diameter, that's not possible. So I hope this video will show that skin turning. Nope. There you are, you can just see the steel ring built inside the tail skin there. So shield, 1,000 tons, back up, 1,000 tons. TBM length, 125 metres. So well, we built the base slab here. It's the permanent base slab for the railway. There was challenges with gypsum within the ground, so we had to deal with the swelling ground with that. That was all built into the base slab before the TBM launched. So last year, we managed our breakthrough on the 22nd of July. That video's not going to work, is it? There we go. So, key figures, 125,000 cubes excavated, 790 rings installed, and our best week was 65 rings, which works out 130 metres in the week. Did that drive in 240 days, with a bit of a slow start, but towards the end, once we got past the learning curve, we had some nice performance towards the end. Best day, I think, was 13 rings in the day. It's almost 2 million man hours worked. Got 220 labour, mainly from Tunnelcraft, and 40 staff working on the project full time. This is Mark Thurston, who is the director, CEO of HS2, and next to him in the blue helmet is Mark Harper, who is the Minister of Transport. So he came through to do the first drive-through of the tunnel on HS2. So as you can imagine, that was quite a complex organisation to get him on site. So once we'd broken through, this is one of the big challenges there. In the early days, it was, do we turn the TBM round and come back the way we've come, or do we... Could we kill the sound? Thank you. Or do we disassemble the TBM and take it back to the start again? And the early decision was to take it down and dismantle it and bring it back. So the shield was dismantled in the south portal into its various constituent parts, cut ahead, and the tail skin being the largest parts, main drive being the heaviest part. And the gantries were pulled back through the tunnel using a herring caterpillar system. We split the gantries, the 4 gantries into 2 gantries, and we just jacked them forward like that, like a caterpillar going out. That worked very successfully, took them out in just over 2 weeks, including the installation of all the steelwork. We had to, massive planning and coordination efforts with all the third parties involved. Ufton Village, we had to go through Ufton Village, which is here. We had Warwickshire County Council, HS2, local police, BT for all the services going over the road. We had tree preservation orders we had to get in place to remove trees that were in the way. Warwickshire Power. In the end, along there, all the lines were cut out. We only had one telecom line there going to one resident, which is a problem in the end. Just before the cut head went past, we cut that, drove the cut head past and reinstated it. So as you can see, it's a rural site, so we've had issues with stakeholders and maintaining very low volumes of traffic as much as we can. So TBM came back. So we have to rebuild it. So to say the TBM came back in its parts, came back in 11 parts in total. So we had a 500-ton crane there, and there you can just see the gantries coming out on the caterpillar system. So there's a lot of lessons learned from Launch 1, especially around the launch cradle design and the anti-roll device. We modified that, and we had a much more successful launch for this drive here. So once the gantries came back, they came back in drive 1. We had to translate them across to drive 2. Original idea was to slide them across, and in the end, what we did was we used them with SPMTs. We pulled them all the way back up our MSV road, and then drove them back in again. And that was very successful. I was going to see if that comes up now. So, modes of operation on the TBM. Once we launched in a full slurry mode because of low cover. And then once we got 100 metres into the drive, we then switched to a semi-closed mode where we ran with an air bubble in the top of the chamber. This had a number of advantages. One, it reduced the total thrust pressure, and another one is it massively reduced the amount of clogging we were getting from the ground. There's 120 days from breakthrough to relaunch. We did it with 2 days to spare on our programme. This is a massive achievement for us. As a lot of people said it couldn't be done. We managed it with 2 days to spare. So down the south portal we broke through. That's the south portal reception box there. We also have a green tunnel where the A425 will be diverted back over. And we have a porous tunnel here, which we'll go into in more detail. So looking at the south portal there, the main difficulties we face there is the site is split by the A425. And we also have an 11 kV running at 90 degrees across that as well. So the site has logistical problems there. So the idea is we're going to move the 4825. You can see the works have gone on here to allow that diversion to happen. Then we can extend the green tunnel into the porous tunnel here. And once the works are finished, we'll divert the 425 back. Green tunnel and reception box, diaphragm walling, 25 metres deep. Due to the ground swelling conditions there, we use core deck on the underneath the base slab. Top-down construction. One of the issues we had as well, and you'll see it better in the next slide, is that there is a polo field. We're next to the Dallas Burston Polo Club, and he had some very expensive lawyers. There's just an overview there. You can see here, here's the polo fields. We just nibbled into his polo field here, saving the other 3 of them. So we went to his place for our breakthrough party, so we've made friends. So at both ends of the tunnel, we have 2 MEP buildings, which were the support buildings for the rail system contractor, and also in the future, there'll be where the operator of the network will have offices and base there. The porous portal, which we have at both ends, is a portal with openings in the roof. So as the trains are hammering in at whatever speed it is, who can tell me, the pressure wave is then dispersed and also reduces the noise. And I just learned a fact before I came here that the trains, when they're running at top speed, they'll be in our tunnel for 29 seconds. So it's an awful lot of effort for 29 seconds. Okay, Jules, I'll hand you back to Bromford.
Thank you, Mark, for this amazing overview of the tunnelling journey in Warwickshire countryside. We will now focus on the second tunnel, twin tunnel of Sublot 1, which is located, as I was saying before, in the suburbs of Birmingham. So compared to Long Itchington, so we're going to see it here. So compared to Long Itchington, we're actually contemplating a tunnel 3.5 times longer, which requires the construction of an intermediate shaft that we can see here, and is actually here in the middle, and 13 cross passages. The diameter is actually smaller than the one of Long Itchington, with an excavation diameter of 8.6 meters, due to the line speed reduction when they enter the city or in the vicinity of the city. The completion of the drive, which is a slight difference with the methodology that Mark just explained before, will require 2 TBM actually, boring partially at the same time. So one is a new TBM that is arriving brand new, as in being assembled at the time. We'll see that later. And the other one is a now famous Dorothy that Mark is very much taken care of on Long Itchington. That is to be actually dismantled and reassembled at Bromford. So the particularity of Dorothy is that it was already configured to be reconfigured at the end to fit in a smaller tunnel. And it's just fitted with a new shield, a brand new shield, and then it can go all over again for its actual third drive. And we are doing the same with the STP. And you're going to see it poses some challenges in the next slide. So on the contrary to Long Itchington, the segments are slightly different. In Long Itchington, I don't think we've mentioned that, but it's actually fiber reinforced, steel fiber reinforced segments. Here we're looking at reinforced segments, with only polypropylene fibers inside, but it's actually with the real cages due to high pressure and ground conditions, which are heavier than the one at Long Itchington. So other design challenges we can mention are the jacking pressure and the passing of the M6, which we kind of see over here. So the M6 is here, so very close to our tunnel, and we're going to have a specific view on that challenge afterwards. So in terms of geology, and that's interesting and will enable us to fully take into like the lesson learned from Long Itchington is the fact that we are facing pretty much similar soil of Mercia mudstone. So the experience that we are developing in the way we operate our machine, which is also a variable density, will be much useful in Bromford for us to reach our production targets. So the slight difference compared to Long Itchington is the fact that we are facing higher pressure of water. So we are slightly above in some areas 3.45 on short section, mainly after the shaft and before the M6. So we are trying to reduce as much as possible the intervention in those areas, of course. The ground cover in itself ranges from 5 meters to 35 meters, as we can see, with an average of 27 meters under the M6 viaduct. So here we can see it's different from the countryside. We are inside the city. It's a very urban area. So hence the presence of multiple key interfaces along the trace, among which we can name, as you can see, so we have the EA with 4 crossing of the River Thames, which is close by. We have an SO pipeline that is going around here and close to the site. We have national highways. I was mentioning the M6 just before. And we also have a national grid with a main line powering Birmingham. We also have 112 assets in the zone of influence of the tunnel, composed of mainly 32 warehouses, 52 houses, and all the rest that is mentioned on the slide. So with HS2, we are very much in collaboration in that to follow the process of sending the building support notices, performing the defect survey, and installing all the monitoring equipment along the way. As I was saying before, one of the key elements in Bromford, and mainly one of the most challenging in terms of design, is the crossing under the M6. So as you can see, we are very close. We are in the vicinity of the M6 and crossing, and like crossing here and going alongside for quite some time. Actually, the original design was very much parallel to the M6, so we had to reconfigure the tunnel so that we can minimize the interfaces between the two. So the M6 viaducts, for those who don't know about this one, is one of the longest, or the longest in the UK. It's 3.5 miles long, and it's probably one of the busiest at the peak hour. And it was constructed nearly 50 years ago. So, of course, the monitoring is key. We have started 4 years ago, as per national highway requirements. We are to test 130 columns and evaluated them. A coring and testing of the pile caps is currently going on, and the potential reinforcement of those is under evaluation by the different parties. So we are currently basically evaluating what we have to do and if we have to do something. So we will, of course, closely monitor the boring loss of the TBM as it goes close by to the M6. The good results we have from Long Itchington, which are actually lesser than what we have anticipated in the design, kind of give us good hope for the Bromford tunneling. We're actually at 0.13% of loss, whereas the design was taking into account 0.5% of boring loss. So we hope to have good news along the way, which would help in this case. Coming back to the east portal, so as you can see on the screen, it is the configuration of the final structure. The building you can see on the side is the main building. So of course, for a lot of different constraints than the one of Long Itchington, we cannot put it on the side. So we put it on the side, but not necessarily far away. So we had to create this structure in the middle for the circulation. But it does actually take the same role. These are the aerodynamic structure, pretty much the same as the one at Long Itchington, dissipating actually the noise and the air pressure of the train when it's entering or exiting the tunnel. We also can note the presence of a sump pit, so here I've put some crossing sections on what we have. what it looks like internally. So this is the sump pit, so we have pumping station, pumping out of here, all the water and ingress. Here is a view on the final configuration of the east portal. So we see that after the portal, so actually the tunnel is going this way, up to west, we have a long cut, the water earthen cutting, which is a long way. We also have all of a development project of landscaping around, and here we see the final render of the building. So we have tried, or at least architecturally speaking, to blend this as much as possible and minimize the visual impact. So what you see is actually a tile cladding solution which has been retained, and we will potentially have the presence of a green roof that is designed. Now, how we organize to deliver that? So this is the view of the site. So we have quite some challenges over there. So the setup is different than where we are in the countryside, especially that it needed to support the operation of 2 TBM and not just 1. The STP2, as I was mentioning, will need to be reconfigured to fit here. So in Long Itchington, we were blessed to have quite enough space to put the STP the way we wanted, but now we have to reconfigure and reshuffle everything so that we can actually fit it to the last, like the missing tooth in this whole area. So we have also the Birmingham Road cutting the site in 2. So here are the offices, here is the site, and the box is just here below. So it's kind of a long site. We have much more like houses close by, which is also, of course, presenting more noise interference with our works. Another particularity that we can mention too is the presence of the WPD substation that still needs to be built, probably early 2024. Not on time for us to launch actually the TBM, so we are constructing a generator farm just next to it. To minimize the impact of a generator farm, we're also trying to reconfigure the grid, like the energy grid that is around and available in the area, being especially mindful about the harmonic compatibility of the different sources of power. So we are looking at combining a 4 MVA with a 3 MVA so that we can power up the TBM correctly and minimizing actually the need of the generator farm. As information, the 2 TBM will require roughly around 12 to 15 MVA to operate. So considering the configuration of the site, that was just presented, so just for you to understand, so the site, the reception mock is over here, so we're looking more toward the east, actually here. So all the motorway is difficult to move in an urban area, so as it is in Long Itchington, we are reusing it inside the site and avoiding to have HGV running on the local area and local roads. So in Long Itchington, we are avoiding roughly around 30,000 lorries journey. By the use of a conveyor. And in Bromford, we're going to go with a slight different methodology, otherwise the conveyor was very long for us to reach the destination point, so we are going with the use of ADT. So we're going to have 19 ADTs running at the peak, and this will probably avoid roughly, as an idea, 250,000 movement on the public highway, which of course, I think the neighbor will be thankful for that. So we have to move roughly 1.8 million tons of material to be transported in those areas close by, which is in the boundary of the site. So on that slide is just to present where we are with the works. So this is what the site looks like. So you much more get the impression of corridor that is Bromford. We are currently in the commissioning of the first STP. So we are looking at Q3 for the launching of the first TBM. We also are finalizing the civil works inside the box, the cutter head welding, and the gantry pre-assembly has just started. So the next step, of course, will be the assembly. So whereas in Long Itchington we could launch the TBMs directly in front of the tunnel with the 4 gantry one after the other, and here we go. In Bromford it's not possible because we, of course, there is a kind of a shaft. So we need to assemble the gantries close to the STPs, to transport them with the SPMT, and then we have a whole sequence of shifting them, moving them inside the pit so that we can launch properly. So it's roughly the same method than the one that we have used in Long Itchington with the thrust frame, the dolly ring, the steel ring, and the 4 temporary concrete. Here we see the cross-section on how we're going to launch under the 5-meter cover. The other big challenging for 2023, apart from launching this TBM, will be, of course, the dismantlement at the Long Itchington Wood Tunnel, the dismantlement of the machine, the TBM, the transport, the reconfiguration, the reassembly at Bromford, everything must be wrapped up in this year. So it's pretty a big challenge which we have in front of us. As I was mentioning before, the particularity of Bromford is that it's having an intermediate shaft in the middle. So it is positioned between the two lines and serve multiple purposes. Services, as we can see on the left. We also have ventilation here and accesses on the right. So actually it is a cross section, so there is 6 points of contact with the tunnel on the two sides that we can see on the figure on the top right. And of course we won't see any of it when we overfly because it's all topped by a head house. So the outer diameter is 21 meters. The interior one, if we take into account the secondary lining, is 15 meters. We have 26 D-wall panels surrounding it, whereas the head house is supported by 156 CFA piles. Again, same type of render than the one at the east portal. So this is the final look. So when I say we won't see a lot from the outside, so this is what is inside in terms of utilities and services for the tunnel in the middle. On the top, the concrete structure, and then the architecture all around it, which is again minimizing the impact, the visual impact that we can have with this facility. So we can see the challenge in coordinating the mechanical and electrical in this kind of building and the ventilation and everything to fit everything which is going into this intermediate shaft. So how we organize. The site is also quite constrained. Same type of urban area, and this one is really a small area. When you go over there, you do realize that it's a very small site to operate. So we need to consider mainly the main interference and the main challenge we have in this site is the presence of the national grid pylon. So we have this massive pylon, which is, as a fun fact, the same size as the shaft. So it's one of the main line which is feeding Birmingham. So of course it has zone of interference. We can't do the D-wall the way we want, the pile the way we want. We need to be careful in every lifting operation. So this is kind of restraining the type of operation we can conduct. And of course, we need to take it into account at every step in terms of safety. So an assessment has been done of this pylon because if you remember, the shaft is between the two lines. So we're going to have a line pretty much here. The other one which is close by. So of course, we need to assess if this pylon is going to move in any way regarding tunnel. So we are currently investigating that, and we are in relation with between HS2 and National Grid to assess what to do as a mitigation measure, and this will start soon. How we will do it is pretty much a standard methodology. So we've done the D-wall with an hydrophase and taken the surplus with a VACX. The excavation will be top-down with gecko skip, so it's pretty much classical methods. When we reach the track plus one level, we have to do this system of tracks and then continue underneath with the secondary lining up to the base. What is the challenge in terms of timing is that the base slab, which is going down there, must be done and casted as well as the track plus one before the first TBM passes. So it is one of the main constraints inside of our program. So it kind of race against the time to reach that level before the first TBM actually reaches the structure. The rest of the structure, once everything is done and the TBM passes, then we can start climbing up with the bottom-up structure, mainly the plenum, and then we can also go underneath to do the adits and caverns. The monitoring is quite extensive. As I was saying, we are closely monitoring the pylon, so we have installed a lot of different means of monitoring to closely monitor what is going on and to ensure national grid criteria are met. News from the site. The excavation has started, actually. So we've completed all the D-wall by the back end of August of 2022. And on the 9th of January this year, we have really started the excavation process, and we are looking at starting soon the secondary lining. So I didn't mention in the introduction that this is actually some warehouses. Here we see we have network rail. This was the shaft. And on the top of it, it is a contaminated area because it's an old car auction area. So we need to take that into account into the first 4 meters of excavation, which we have passed now. Completing the overview of Bromford Tunnel, of course, on the other side, we find the west portal. So roughly same configuration than the one of the east portal. So we can see the section on the screen with the vertical situation, the permanent props, capping beams, diaphragm walls, the base slab, the sump, which is quite bigger than the one on the east, some tension piles, and the aerodynamic structure for, of course, exiting the train and taking into account the noise and pressure and dissipation. So this is located at Watchwoosh East, which is going to be the main maintenance depot, one of the main maintenance depots in the area. And same type of building on the other side. So both TBM, so we don't have this famous operation of dismantling and transporting and caterpillar system that Mark was talking about, because here the 2 TBM, of course, are going to be dismantled fully at the west portal. So we are looking at doing the other type of activity just after the tunnel has passed through. And we are currently executing the D-wall on the other side. So this is a pretty much accurate and existing picture on what the site is looking at the moment. So to feed all of that tunnel, we of course are relying on a precast factory. So our precast factory is located in Avonmouth, which is inside the Bristol port area. It is a BBV entirely production. We are looking at reinforced concrete segment of 2 meter width with an automated system of carousel. As I was saying, the factory is directly managed by BBV. It is actually the factory that was also doing the segment for HPC in Clay Point C, so it allowed us to take a lot of lessons learned and embed them in the way we wanted to do the processes, to optimize, and to also reach some of the goal of sustainability we have by reusing the facility which was already existing. The location is, of course, quite ideal. It is close to the port, and we can have an easy access to the M5s. So here is the process in very, very, very accelerated. This is how it's looked like in the chain. So the production line has been adapted to cope with the longer segment, and the lesson learned, as I was saying, of SPC had been embedded in the current operation with numerous safety features. So we've analyzed each and every one of the stations to ensure the safety was prime, and that all the work was correctly analyzed. Of course, we have the lean mentality in the way we are approaching this kind of works. So we see on the left the type of reinforcement we have and the segment which are partially stored inside to avoid some thermic shock. And then, of course, they are going to be stored on the yard outside. So the automated carousel line is fitted with a steam curing, with 3 steam curing chambers actually, and they are disposed in the pre-storage area, as I was saying. So we are looking roughly at 6,000 trapezoidal rings which are to be produced. All of them are embedded with gasket that we have to embed prior to concrete. And the mix design is containing some polypropylene fibers. The production is done in 2 shifts with 15 staff and 100 labor, give or take, which are organized in 5-2. The real production of the segment have started on the 5th of October, so a few months ago, and we have already casted more than 82 rings. So lastly, I could not finalize the overview of the Sublot 1 activity without mentioning the special care for the community as stakeholder that we are having on this project. This is actually one of our core values. So the dedication of the team to share its passion of tunneling with the younger generation, residents, YouTuber, rail enthusiasts, journalists, politicians, has been really relentless. To give you an idea, we had more than 600 visitors in 87 visits hosted in 2022. So in the video that you see on the screen, we actually have hosted an open door event to reach out the local universities. We have also launched several programs with university to integrate apprentices. So we are looking at 5% of apprentices to be embedded in our workforce and staff, summer placement, etc. So, and we're also working with tunnel skills, for a program of tunneling apprenticeship that they are being developed and to implement it on our site. So I really hope you have enjoyed this presentation, and I would like to praise the work of the entire Sublot 1 team, which is visible, I guess, through those slides, in order to build this fantastic infrastructure for the future. So thank you for your attention. Thank you.
have we any questions for either of the presenters?
Where to start? The machine has worked well in the ground conditions. We had some clogging issues very early on, which we resolved by going into the semi-closed mode. The Long Itchington Wood TBM was chosen as a proof of concept for Bromford. Bromford has the crossing under the M6, so we needed to give Department of Transport a certain degree of comfort and a nice warm fuzzy feeling that the variable density machine could handle the ground with minimal ground loss, which we've demonstrated with only getting 0.13% face loss. So that was the main reason for choosing the variable density at Long Itchington. Also, Jules, the machine was then going to be taken from Long Itchington Wood to Bromford.
And it reaches the production that we have expected and planned at the beginning of the journey, so we are quite satisfied with the machine, the way it operates at the moment.
Question down here.
Thank you both, that was excellent. But I've got a question for Mark, sorry Mark, about the slurry treatment plant. You mentioned the in parts very plastic geology and your clogging issues, but the pictures of the cake in that circumstance were very impressive. So I suppose my question is did you pre-treat the slurry? Was it always that good?
There was no pre-treatment done, and no, it wasn't always that good. We had a difficult learning curve, and once we got past that learning curve, we're getting filter cakes now with 30% water volume in there. So that filter press is working exceptionally well. And that ground is now going to Sublot 2, and has been incorporated in their earthworks with minimal lime treatment going on there.
So there is a post-treatment to be able to use it, mainly in landscaping.
That brings a supplementary. Are there any, if you're lime treating it, are there any heave risks with any of the sulfates that might be left in there? Normally high sulfates and lime treatment don't go well together. You need other substances.
At the moment, the results we have are pretty good. And we actually, one of the other features in the research for sustainability, we also are using partially the ground risings, also as part of mixture for stabilizing the ground.
One at the back there.
Thank you. Bill Gross, independent consultant. Thank you. Very interesting talk. Lots and lots of facts and figures there. I'd like to ask a question about cost. If you took account of the TBM and the segment manufacture and excavation and work and so on, just the cost of the tunnelling, do you know how much per metre or per kilometre the TBM tunnels have cost?
What we budgeted?
Yeah.
No. The answer is no.
The answer is no.
So the answer was no, we don't know.
Could you find out?
Yeah, we could. Yeah, we could. If you want to get in touch, come and see me. I'll give you your email address and I'll let you know.
Okay. Next question. There was one down here somewhere.
Good evening. This is Aryan from TJB, Tunnel Engineer. Thank you first of all for the presentation. Very interesting and insightful slides. My question is also about the TBM. You mentioned that you're going to reuse the TBM in Bromford. What sort of factors did you consider in making that decision? Why not the new TBM? And how did you assess those factors to come to the decision that it would be better to reuse rather than procure a new one?
It is an interesting question, and actually I would say the main driver is the time. So give or take that if we were to use the same TBM, we're looking at 14, it would take 14 months to drive. So even if the TBM1 that we're using, the TBM2 actually of Bromford that is going from Long Itchington is having a slight delay compared to the first one, it is still a massive saving in time to use the 2 TBM. And it is already there, so it's good to use. And if we were to wait the Long Itchington to launch Bromford one, then it would be even worse. So there was a risk-benefit assessment that has been done with HS2 to go to that decision.
And would you say it was mainly time which was the driver, or it was also saving carbon and the environmental side of it as well? Like, how would you compare?
So
the main driver of the decision, would it be just time and the costs?
Yeah, I would say the program most probably. Yeah.
It's more the program. Sure, thanks.
The TBM at Long Itchington Wood was future-proofed for Bromford in that the main drive, the screw conveyor, were all sized to suit the Bromford Tunnel.
Okay. Question here, Divik.
It's Richard Sutherland from Murphy's. I was just asking, you mentioned squeezing ground there. I was quite keen to know whether the ground squeezed like it was potentially assessed to, or whether you didn't really see that much evidence of the squeezing during construction.
No, not really.
In the tunnel, we saw very little evidence of squeezing ground there. We parked the TBM up over Christmas, we came back, and we started off absolutely no problems at all.
So how much sort of overcut did you have on it?
Off the top of my head, I think it's about 20-25 millimetres.
Okay, cheers.
Yep. But I can find out for you more details.
Any more questions? Haven't you? Well, they're definitely going round somewhere. It's coming down the middle, I think. So it's on its way down. Okay. Any more questions? Yes, there's another one at the back there.
Hi, you mentioned you had a really tough learning curve for this machine. What was the toughest part of the learning curve and adapting this to this machine? Because I have worked on EPBs and open machines before.
So I would say it's multifactorial a lot. So we have to consider this was the first tunnel and probably the most advanced work in HS2 Area North. So it's also not only a learning curve for the tunnel but for the whole organization. So everybody knows that there is difficulties also in the country to recruit, to staff up, to have the competency of the people. We needed to go in a lot of trainings. We need to learn another organization. And of course, we needed to understand the behavior of the machine. So actually very little experience of tunneling inside the Warwickshire countryside with this kind of Mercia mudstone. So even though there was one experience previously, it's not like a massive experience to build on. So we had to rediscover the ground. As we say, the variable density is kind of a new machine too. The STP is having its tweaks and pieces, so all of that contribute to those factors. And yes, the ground was behaving very differently than what we had expected originally when we've done the ground investigation, whereas the weathering actually of the cutter head on the ground is creating a sort of sticky paste, which is much more difficult to handle. So all of that we had to overcome as an organization, as a team, as an IPT, to be able to reach. And at the end, we managed to get a learning curve, and now the machine is ongoing pretty well. So
there was a few technical issues on the launch of the first that we took. We sat down, had lesson learned workshops, and identified where we hadn't so much failed, but we'd not optimised our production, such as the anti-roll devices were absolutely massive and interfered with the segment supports. So we modified those for a lighter anti-roll device, and that meant we could pre-build our segment supports, which saved us a massive amount of time.
In comparison with like a normal EPB or slurry machine, is it more easy to modify while working? And
modify in what way?
as in, like you said, you changed the anti-roll devices and that, and made them lighter. Is it during the operation?
what is easy is to pass from slurry mode to air mode, which are the two main modes we are using to excavate. So we cannot use the air mode every time, which is when we maintain the bubble of air inside the chamber, because when there is low cover, it's more difficult to manage. So this is the easiest part, let's say so.
Yeah. So we've only operated the machine in slurry mode. We haven't switched it into an EPB mode at all. We've just gone with the slurry mode.
Okay, yeah. Thanks for the answer.
This requires a lot more modification if we would want to go to that modification. It's possible, but it's more work, so we would have to stop the machine, reconfigure it for its use.
Thanks. By the way, I'm Arlaud from London Bridge Associates. Thank you.
Okay. There's one at the back there. Yeah, I see you. We'll get to you.
Hi, Dan Garbett, Magnox Nuclear Decommissioning Authority. So I think I know which previous project that you're referring to there in relation to in that same area which was tunnelling at Mercia Mudstone. I believe there's a 2003 paper on the disaggregation of the Mercia Mudstone when tunnelling happened and the machine got stuck. So maybe you could just talk a bit more about that lessons learned and how you took the learning, because obviously you clearly did, but it would be nice to see or to hear a little bit more about that lessons learned process before you undertook your tunnelling in Mercia Mudstone, which is relatively difficult or relatively unheard of.
No, I don't want to do that one at all.
So, I mean, again, as I say, it's also a matter of lesson learned inside the organization. So yes, it has created some difficult condition, and we had clocked a few times the cut ahead, to be fair, which helped in Long Itchington is the fact that as the water pressure was not high, we could not make free air intervention. So declock the cut ahead, learn. We had a lot to learn into the parameter, and again, the relationship between the TBM and the STP is also important. So we clocked a few times the STP too. Especially in the filter and the descending unit. So I don't know if I answered the question, but the question is about how we embedded the lesson learned of our own project.
Yeah, did you change the ground investigation?
We didn't change the ground investigation at the end. We revisited the data, but we had first to understand what was happening and why the behavior of the ground was different from the one that we found in the ground investigation. Actually, the ground was close, but not in the sticky area of the Mercia Mudstone when we investigated. But the material, when we were excavating, it was clearly inside that area. So we had to understand why it passes from one side to another and how we can prevent that to happen. So we modified also the tools on the cutter head to put more reapers. And we operate with what really has been a changer is also the way we operated the air mode. But now, on the contrary, we also, by modifying the parameters, so during the turnaround, we also modified some parameters on the machine to modify the amount of slurry inside the cutter head. So we also have taken the lesson learned, and now the operation in slurry mode is also quite successful on the tunnel too.
Will you produce a paper on it?
I have no idea. We will first apply it to ourselves in Bromford, I hope. Okay. No, but yes, I'm sure the paper will follow, of course, into the tunneling world. I'm pretty sure once we are finalized, compiled. So internally, we are compiling the lesson learned, and the fact that the team is also going on the two sides, it's helping us to consolidate and improve, and we still have more run to go. So we already see all the benefit of the lesson learned that we have embedded on the second drive. Which one we say we have done 120 rings in what was the figure in 30 days, 30 and something days. So the amount of reflection we've put in between the drive to reanalyze all our parameters has been massive too. So it was not just about the technical complexity of moving the turbulent, but also how to modify the machine. So we've been in contact with Air Connect. We found another project in Paris, which are sometimes also having some clayey material facing. So we had to, of course, we have also recurred to Balfour Beatty Engineering. So we called the company, we had a lot of technical workshop, and we tried to analyze what we could do best.
Okay. Question right at the back there.
Thank you. Lee Aspen, HMJV. Obviously, quite a number of TBMs and HS2 are using sort of robotic features. Just wondered how successful, or if they had any at Long Itchington, and how successful they were on the TBMs then.
We haven't taken any of those novel features that you're seeing on other TBMs. It was a bog standard TBM. There was nothing really out of the ordinary on that machine. Sorry to disappoint you.
No robots.
Question there, Divik.
Hi guys, Neil Hancock's current chair of Tunnel Skills. Lovely to hear mention of your apprentice programme towards the end of the presentation. I just wonder, representative numbers in various trades, so tunnelling apprentices, staff apprentices, what's the legacy as far as the industry in the UK is concerned for apprentices?
I guess it's too soon to talk about legacy, I hope, in the end. But so we try to take some apprentices on board, to be fair, but it's not easy. It's not easy to recruit, especially in the younger generation. So we have the technical program. We have a few in the electrical ground. We also have a few in the staff, in apprenticeship. But at the moment, we are trying to work with our 5% of our apprenticeship, but it's not as easy as we would like. And the university, we are constantly chasing to have some good profile, integrate them, because we firmly believe that part of transmitting the lesson learned is also having the continuity within the different sector of the staff, within the different generations of the staff. So we are very keen on taking people on board and promoting the apprenticeship. Yeah.
Our labour supplier has been out in the market looking for apprentices. I think working with yourselves as well to do that.
Brilliant, thank you.
But what we've done also internally a lot is and this I need to thank Tunnelcraft too, has been a massive help into casting and putting up to speed the different workforce. We had to work with people with very, very different background. We could not benefit from already pre-organized teams, so we had to put together a lot of building up of competence, especially at the beginning, which I mentioned was part of the lesson learned and learning curve.
There's one in the middle there, Divik, behind you.
Hi, I'm Chris Peaston. I'm an independent concrete consultant. Your slides showed bar-reinforced segments. I wondered whether you considered alternatives.
So Long Itchington Wood was steel fibre reinforced segments, apart from those segments around the cross-passage openings and at the two portals. Bromford is traditional steel reinforcement. Was there any discussion on that, Jules, to go for steel fibre?
Yes, they have tried to, but the pressure of the rams and the few other parameters and the pressure of the ground, we have 120 years durability to achieve too. So all that considered, we could not go with two steel fibre reinforced segment for Bromford. So we had to change the design.
The durability is an interesting one, because I would have thought that ones that didn't have bar in it were likely to be more durable than the fibre reinforced segment.
Yeah, that's correct.
So why did you make that choice then?
Sorry again?
Why?
It was mainly down to the jacking
for me,
pressures.
Yeah, for me, it's the jacking pressure and the resistance of the segment in the first place.
Okay, that's great. Thank you.
Okay. Question down the front here.
Mark, you mentioned during your presentation that there was a decision to be made either to take the TBN apart or rotate it in position. What was the thought process or the factors that affected the decision to take it apart and transport it instead of rotating it in place?
It was programme driven. If we wanted to launch the TBM at the South Portal and come back from the South Portal, we would have had to have had the South Portal, the Green Tunnel and the Porous Tunnel ready for the TBM to arrive there, and that was never going to be the case with the planning problems that we were going through with council.
So we basically just done the box on the other side, just to take out the cutter head and the tail skin.
Okay, thank you.
Plus logistics would have been a problem as well, using MSVs, going in, reversing, going in and out again. So that was one of the smaller problems there.
Thank you.
One down here.
Peter Jones from Sensieve. There wasn't any fantastic presentation. I didn't see any mention of monitoring, tunnel deformation monitoring after you've done the installation of the panels as the TBM moves forward. Was it something that you did, or you just took it for granted that...
No, we installed instrumentated rings within the tunnel, and they are constantly monitored for drive 1, and as drive 2 is going past, we're going back in and checking those as well. We've done an ovalization survey with LiDAR to check the ovalization of the tunnel, and that's looking very, very good there. So we're not seeing any movement within the lining. And the stresses coming out of the instrumentation segments are well within design parameters.
Can I just ask, was that sort of optical deformation monitoring or stress monitoring of the rings?
It's stress monitoring rather than deformation. Let's say we did the LiDAR drive-through, which gave us some very good results.
Okay, thank you.
Any other questions? There was one down here earlier. Yep.
Thank you. Hayden Davis, retired, but ex-High Speed 1. Just further to the other question about the special rings at the Avonmouth factory, the ones that had steel bar cage reinforcement. Just to check, you didn't put fibre as well in those?
Not steel fibre, polypropylene fibre, yes.
Sorry?
Polypropylene fibres we put inside too, in the mix, in the concrete design mix.
To protect the cover concrete. Okay, thank you very much.
Okay. Any other questions? Right, well, if there's no more questions, we'll wrap up the question time. And let's thank... Right, we've got some slides now. And the very most important one is the first one. The sausage and chips and pasty and chips are back, and so is the bar, and both being sponsored by Vinci Construction Grand Projects tonight. So, yep, and that is here to stay. So let's see you all back here next month. Going forward, there's quite a few slides here on future events. Please make a lot of notes or go onto the website regarding the dates. We've had some issues with obtaining this room going forward for this year. That was partly due to numbers that have resulted from COVID, and also probably down to the fact that we haven't had the sausage and chips as well, and the bar. So unfortunately, we aren't the third Thursday of the month for the whole of the year. So please do make note. Don't rely on the normal third Thursday. Look at the emails that come out as on the membership. Look at the website and look at the various dates, please, going forward. So the young members have a Think Deep Nigeria on this Sunday, and there's a way of connecting onto that. It's via an online Zoom at 7 o'clock our time. So that's that one. The BTS specification for tunnelling, 4th edition. The peer review is going on, or going to go on, and we want your final comments to be in by the end of the month on the specification, so we can finalise and progress it to get it issued. Thursday, 9th of Feb, is our yearly joint meeting with Min South on the Kidston Pump Storage Project in Australia. 6 o'clock. Also, there's a couple of 1 or 2 events that might be starting at 6:30, as well as the room changes and the date changes. We've also got 1 or 2 times that we have had to put the meeting back by half an hour. Young members have a February meeting, vacuum waterproofing membrane systems, and that'll be here on the 16th of February. They also have a seminar day, the young members, transferable lessons in tunnelling and geotechnical engineering on the Wednesday the 22nd of February. And that one is in Dublin. The March BTS meeting is geopolymer concrete in tunnelling. This one, as you can see, is a 6:30 start here at the ICE. Young Members Workshop is down for the 23rd of March, ground investigation. Speakers to be confirmed. Harding Prize is on the 13th of April. Applications need to be in by the 10th of February, please. The rules are on the website, and that is a 6 o'clock start here. The annual dinner, as I mentioned last year, we've moved that forward a little bit just into April because of the King's coronation was going to go on the Saturday after our dinner on the Friday night. So we thought there could be issues with hotel and accommodation and possibly hotel prices. So we've moved it a week earlier. Booking will open on the 1st of February. We understand there's a lot of people eager to get booked, so please get in early, otherwise you could be disappointed. Also, that's going to go live, we've put out some initial flyers, but the booking is going to go live in early February, is the BTS Design and Construction course, which is going to be held from the 3rd to the 7th of July this year at Warwick. He's talking about himself. So please look out for that and see who you've got within your organisations that could benefit from the week's course covering all aspects of tunnelling. This one just needs to give you a second to read this one. This is an update from the Transforming Tunnelling Safety Group and where they've been progressing in December. I'll let you read that for a split second. Of course, all these are on YouTube, so if you need to go back to find any of this information, it can be found there. You can watch the whole event again. And finally, how to contact us, but also going back to the 50th anniversary, we are still working on the book. It is progressing. It has become quite a large exercise. The amount of information, the whole book has grown in size. It is progressing that hopefully before the end of the year we will have a launch event planned for everybody to come down, more than likely here at the ICE. We haven't confirmed exactly what date yet, but we will arrange a launch event. Looking at the thickness of it, I think you all need to go out and get new coffee tables so that you can put it on the coffee table and read it for the next few years, because it has become quite a piece of work. A lot of items from a lot of people over the years, so it should be very interesting to read. So that concludes tonight's meeting. we'll see you all in the bar for beer, sausage and chips. Hope you enjoy it, and it's glad to be back.